We spend a lot of time worrying about the immediate crises right in front of us, and for good reason. It's easy to assume that if we fix our planetary problems, this Earth will remain a stable, comfortable home for our species forever. But the universe has a strict expiration date. Our first real cosmic eviction notice arrives in exactly 1 billion years. The sun is constantly burning through its fuel, growing hotter as it ages. Every 100 million years, its temperature increases by about 1 degree. That extra heat will fatally disrupt Earth's carbon cycle, suffocating plant and animal life. Without that cycle, the surface temperature will steadily climb to 47 degrees Celsius. The oceans will evaporate completely, leaving behind a dry, dead rock. Hopping over to Mars might buy us a little time, but it's a severely hostile environment, and the sun will eventually scorch that too. To survive long-term, we must learn how to outrun the death of our entire solar system. Fast forward 10 billion years. The sun will exhaust all the hydrogen in its core. To keep burning, it will start consuming its outer shell, expanding outward into a massive red giant. That expansion will swallow Mercury, Venus, and most likely vaporize what's left of Earth, stripping it down to a bare iron core. After burning through everything it has, the sun will finally shrink into a dim, dense white dwarf. While our sun is dying, a massive macro threat is heading straight for us. The neighboring Andromeda galaxy is currently hurtling toward the Milky Way at 400 million kilometers per hour. When these two colossal star clusters collide to form a single galaxy, the gravitational waves will be intensely chaotic. There's a high probability our dead solar system will be violently flung out of the galactic core and cast into deep space. To make it through this era, our distant descendants will need to have completely severed their ties with the Milky Way, mastering the ability to traverse and populate the deepest regions of space. This graph charts a critical threshold. As dying stars scatter their materials, less and less hydrogen gas is available to form new ones. Eventually, the universe will run completely out of this raw material, and new star formation will flatline. The era of starlight will be over. We will then enter the degenerate era. The universe will become a dark cosmic graveyard, populated only by cooling remnants, fading brown dwarfs, white dwarfs, and dense neutron stars. This presents a harsh biological ultimatum. Physical, warm-blooded human bodies require massive amounts of energy to function, and a freezing, starless universe simply cannot provide it. One theoretical path for survival is uploading human consciousness into digitized virtual environments. These simulation servers could run on the very last drops of thermal energy harvested from those cooling stellar corpses. The thermodynamic decay of our reality will eventually mandate that we abandon physical form entirely. Retreating into a digital simulation might be the only way to keep the lights on for our minds. But even a digital existence has a shelf life. 10 decillion years from now, we will face proton decay. Protons are the subatomic building blocks of everything. When they begin to disintegrate, the physical servers housing our digital minds, the remnants of dead stars, and matter itself will literally dissolve into nothing. This ushers in the black hole era. The only structures left intact across the entire expanse of space will be supermassive light-eating voids. As seen in this diagram of an event horizon, even these absolute voids aren't immortal. Due to Hawking radiation, black holes slowly leak particles into space. Over incomprehensible spans of time, they lose their mass and evaporate completely. Once the last black hole evaporates, any form of physical or machine-based survival becomes scientifically impossible. The universe itself will have outlawed the existence of complex matter. A 1 followed by 100 zeros. That is a Google years. Welcome to the dark era, where the final black hole has vanished. A mysterious force known as dark energy has been constantly accelerating the expansion of space. By this point, it has stretched the universe so wide that the few surviving isolated subatomic particles are separated by unimaginable distances. This is the Big Freeze, a silent, completely empty void where all remaining energy is evenly distributed and the ambient temperature hovers just a fraction above absolute zero. Looking at this desolate cosmic timeline, it's worth remembering where we sit on it today. Humanity is a mere 200 years past the Industrial Revolution. To outlive the Big Freeze, a hyper-advanced human civilization will have to learn how to manipulate physics itself. They might have to engineer an entirely new universe in a lab and migrate our species into it. Our current universe is just a temporary cradle. If the human story is to continue infinitely, our ultimate destiny is to outgrow this reality entirely before it evaporates around us.